This is a good place to pause and consider an important philosophical question. What can an AND do? But more importantly, what can it not do? One huge advantage of ANDs over conventional techniques is that even if a human can't see a pattern in data, as long as it's there, the AND will learn it by example. A human might not be able to see it because A, it might be too complex or abstract for our own pattern recognition system, in other words our brain, or B, we might not be able to identify it because of the amount of data or the data's interaction with other system parameters. We have to be careful though. There's a tendency after playing with ANDs for a while to assume that they can perform miracles. However, shallow networks have limits, which we've already explored in video 24. And another one we need to add to these is so simple that it's often overlooked. There may simply not be a pattern present in the data to recognize at all. The trouble is that in some cases, and often the most interesting ones, we just don't know. This is well illustrated in the case of the health applications which we discussed in video 23. I mentioned there the possibility of using ANDs to diagnose disease. However, this assumes that the disease in question manifests itself as a pattern of some type, and there's no particular scientific reason why it should. Of course, if there's no pattern there, neither humans nor any other technique will be able to predict the disease either. The no pattern situation can be illustrated in terms of linear separability as shown by the diagram on the screen. You can see from this example that because the inputs corresponding to the patterns don't cluster in input space, in the space illustrated by the diagram, different members of pattern 1 and pattern 2 can't be separated easily, and obviously any network trained to classify them correctly won't be able to generalize because there are no general features in the patterns. In such cases, before we give up completely, there are two further questions to ask ourselves. These were covered in video 24, but they might be clearer now. Question number 1. Are there any other variables available from the system which might be used as an alternative to the inputs which we've chosen, and which might yield better results? Sometimes such variables might seem unrelated at first, but it's always worth considering all the available data. Question number 2. Are there any mathematical transforms we can apply to the data which will allow it to cluster in a different transformed space? We've already mentioned Fourier transforms in video 24, but there are many others also available, for example wavelet transforms. If you think that there is a pattern in the data, but it's still too difficult or hard to process, for example because of framing issues, then a deep network or a modular network is probably worth considering, and we'll discuss these more complex types of networks later on in the course. One of the problems with all this is that we often just have to take an educated guess at whether there's a pattern or not present in the data, and simply try and see what happens.